Okay, I'm making this additional video to help with to show you to use your calculator when calculating probabilities of binomial experiments. So if you're watching this video, hopefully you've already read section 4.2 in your text and you know what a binomial experiment is. It consists of n trials, which are all independent of each other, where the probability of a success on each trial is always the same, and it's always equal to p. And of course, a success can be whatever we want it to be. It's basically one of two possible outcomes from each trial. And then the number of x is the number of successes, and that's our random variable here. So the questions you'll be seeing involve probability that x is in a certain range, or x is equal to a certain number. That is, probability that of exactly k successes in n trials, that's really the probability that x is equal to k. And we have a special command on our calculator called Binompdf, and you just have to enter these three variables: n, the number of trials; p is the probability of success on each trial; and k is the number of successes. Okay, so obviously k is going to be a number between 0 and n. So that's for the PDF. That's when you want to find the probability of exactly k successes. If you want to find the probability of k or fewer successes, then we use a different command, CDF, because we don't really want to, we could use this and plug in, calculate this for k equals 0 and k equals 1, and then all the way up to whatever k is. But we can do this in one fell swoop. Okay, this is Binomialcommands, and this is the probability that x is less than or equal to k, which really is the same thing as, x is between 0 and k inclusive. Okay, just to clarify one thing, this is really what we're doing here is we're computing. We have this formula that was given in the text. Okay, where we have n choose k, p to the k, q to the n minus k, right, where q is 1 minus p. Okay, so the calculator will do all this for you. Okay, and then here with Binomialcdf, we're summing up all these values where start when k equals 0, k equals 1, and so on. Okay, the one to keep this in mind is the C stands for cumulative. Okay, so that's how a way to distinguish between the two commands. Okay, so let me just give you an example how you would do this. Here we are tossing a biased coin in which the probability of heads is 0.3 or 30%, and we're tossing it 7 times. All right, so this is a binomial experiment, just like most coin tossing experiments are. N is 7, P is 0.3, okay, and X is the number of heads. Okay, because we'll define a success as flipping a head. So if we wanted to find the probability of exactly 2 heads, this is the probability that X equals 2, and this is Binomialcommands of 7.32. Okay, so now we take out our calculator, and what we do is we're using a distribution command. So we want to use in my calculator we use the get the distribution menu, and in that case we have to go all the way down to number 9 where it says Binompdf and enter this in. So we wanted 7, 3, 2. Okay, and that might help if you get the right numbers in. Okay, and you get 0.3176. We'll round off to 0.318. Okay, so that's how you would do that. In the case you wanted 2 heads or fewer, this is the probability that x is less than or equal to 2. Okay. This is also the same thing as saying at most 2 heads. So in this case, you would just use the binom and get the distribution menu again. And use Binomcdf, and this would, now in this case, this would be Binomcdf of 7.32. So Binomcdf of 7.3, 2, which is 0.647. All right. Now, what happens if we wanted to find probability of 4 heads or more? Well, this is the probability that x is greater than or equal to 4. And the way we do this, we don't have a special command for this, but what we do have is we can rewrite this using complements. Because the opposite, or the complement of x being greater than or equal to 4, is x being less than or equal to 3. All right? So this will be 1 minus Binomcdf of 7.33, which is 0.126. You do this on a calculator. And then finally, if we wanted to find the probability of between 3 and 6 heads, this is the probability that x is less